This is the introductory lecture at the quarry, because I was busy trying to collect samples, so I don't want to repeat anything that was said there. But I thought I'd give you, given the coldness of the weather, I'm not going to talk very long, but I want to give you just a real brief introduction to the volcanic rocks we're going to be looking at this stop, and put them in a bigger perspective here. So this is a simplified map, obviously. Some of this stuff is from Bill Thomas. All the faults and everything are taken from Bill Thomas's syntheses. But the purpose is to show you the position of the Southern Oklahoma Aulacogen here, striking into the craton from the ancient continental margin. And I don't want to say too much about the tectonics, although it's a fascinating story. But as you probably already heard, the reason we have all this magmatism here is this is an early Cambrian rift zone, also called an Aulacogen by many people, that developed when North America, or Laurentia, was separating from an ancient supercontinent. And a lot of people, like Bill Thomas, believe that the pre-Cordillera terrain, now present in South America, rifted off from here, rafted across, and joined South America later. So here you see the uppermost main igneous unit of the Aulacogen, colored in red there. This is a Carlton Rhyolite Group, and as you can see, it's quite extensive in the subsurface. Now, this is a bimodal igneous province. We already saw a bunch of the diabase dikes, and we've got a lot of diabases, gabbros, a big layered complex further to the west in the Wichitas here. So a lot of mafic magmas, and there's also a lot of felsic magmas, the rhyolites, and also some very interesting and extensive sheet granites that came up sometimes right beneath the rhyolite volcanic cover. And we're going to hear more about that tomorrow from John Price. Now, to get an idea of the scale, I should first of all say that this distribution of the rhyolite is taken from the classic OGS Bulletin, published in '64 by Denison and Merritt. And it's really nice to have Tim Denison on the trip with us today, as a matter of fact. It's great to have, this is the 50th anniversary of the publication, so it's wonderful to be talking about these rocks here. So Tim did his master's here. I think he did it in '58. And you were the one that really studied the subsurface distribution of the rhyolites for that, right? Yeah. So if you go with this extent of the rhyolite, and I think part of the northern extent is a little conjectural, but I mean, if it's even roughly true, this is about 40,000 square kilometers of rhyolite, mostly in the subsurface, of course. And it's quite an impressive volcanic field. A lot of people, when you think about world rhyolite provinces, Southern Oklahoma doesn't pop into your mind. However, if you put a map here of Yellowstone and Caldera Complex and the Snake River Plain, it's almost the same size. So that gives you an idea of the scale and probably the complexity of the magmatic system that we only see little glimpses of. But there's two places where these igneous rocks, Cambrian in age, related to the Aulacogen crop out. Here in the Arbuckle Mountains, where we are right now, and I'm going to show you a closer view of that in a second, and over here in the Wichita Mountains, where we're going tomorrow. Now, some of these rocks are not very well dated at all. For example, the diabase dikes we were just seeing, we don't really know an age on those, but we do have some uranium-lead zircon dates from these felsic rocks. They're mostly just published in abstract form only, and they come in at around 539 to about 530. And when you put the plus or minuses in, the data seem to indicate a pretty brief pulse of felsic magmatism around 535. Now, the only ones that have been published are by Bill Thomas and his colleagues, and those are two samples here from the Arbuckles. One sample comes from this little circle here, that's where we're standing, and that sample, according to your GPS coordinates, where's Bill? There you are. According to your GPS coordinates, it must have come from just over there. Yeah. And what was the age of that? Was that 539?
That was 539.